This is the second part of random variables. In this video, we are going to talk about continuous random variables. In the previous video, we discussed discrete random variables. So let's do a few more problems of discrete before we proceed on continuous random variables. But before that, let me write down some formulae which will help you to do some questions. So when terms are in series, the sum of the series is, so for example, when the series is like this up to k, the sum is k times k plus 1 divided by 2, and when it is squared, the sum becomes k times k plus 1 2k plus 1 whole divided by 6. When it is cubed, 2 cube, 3 cube up to k cube, the sum becomes k times k plus 1 whole divided by 2 whole squared. And when the terms are in GP series, so for example AR square, where R is a ratio, AR cube, the sum of the n terms is A times Rn minus 1 whole divided by R minus 1 when R is greater than 1. And when R is less than 1, the sum of n terms is A times 1 minus Rn divided by 1 minus R. So there is a slightly changes. And when there are infinitely many terms, the sum is A divided by 1 minus R, provided absolute value of R is less than 1. All right. Now let's do some questions. Suppose fx is 2x divided by k times k plus 1 for x equals to 1, 2, 3 up to k. Now you are asked to show that this is a valid PDF. So first condition is the value of the function should be positive. So when you put the value of x in this function, you'll see that the value is positive. K is positive, right? K is a positive number, and x, the values of all x values are positive. So the first condition is satisfied. What about the second condition? The second condition is sum of the PDFs of the probabilities should be equal to 1. So summation of fx should be equal to 1. Now let's check this whether this is equal to 1. So the first term is 2 divided by k times k plus 1. Second term is 2 times 2 k times k plus 1, and so on. And the last term will be 2 times k times k plus 1. We can take 2 divided by k times k plus 1 as common. So the remaining terms will be 1 plus 2 plus 3 up to k. And we know that the sum of these terms is simply k times k plus 1 whole divided by 2. And these get cancelled. So this is equal to 1. So this is a valid PDF. All right. So this is how you can show the function is a valid PDF. Let's do one more problem. Suppose function is c times x square for x equals to 1, 2, 3 up to k. Now you are given that the function is a valid PDF. So in this case, this is a valid PDF. This is known. And you are asked to find out the value of c. What is the value of this constant? So since this is a valid PDF, we can write summation fx equals to 1. This should be equal to 1, right? Now let's add each terms. So the first term will be c and then plus 4c, right? Okay, let me write like this. So this is c1 square, c2 square, c3 square, okay, and so on up to ck square. We can take c as common, so this is 1 square, 2 square, 3 square up to k square, and this is equals to 1. Now you know the formula of this. This is simply k times k plus 1 2k plus 1 whole divided by 6 equals to 1. So the value of c is simply 6 divided by k times k plus 1 2k plus 1. All right. So this is all about the discrete random variables. Now let's move on to the continuous random variables. Continuous random variable. So we'll talk about the PDF first. PDF. Now in continuous, PDF stands for probability density function. Probability density function. Notation that we use, notation is fx x, or we can write fx simply. Okay, we do not use this symbol, okay. This symbol is not used in continuous random variable because probability at a point in continuous does not exist. All right, so this notation is no longer applicable in this case. All right, now the definition of PDF is again the same. Fx should be greater than or equal to 0 for all values of x. This is the first condition, and the second condition is we use integration in this case because the function is continuous, so the integration should be equal to 1. In the discrete, we had summation of fx should be equal to 1, but in continuous, the integration of fx should be equal to 1. Now let's do one problem. Suppose we are given the function fx equals to 2 times 1 minus x, and the range of x is greater than or equal to 0, less than or equal to 1. Now you are asked to check whether this function is a valid PDF. So you can see that the range of x is between 0 and 1, right? The values of x is in between 0 and 1. So within this range, this function will be positive, right? So the first condition is satisfied. Now second condition, we need to integrate this and show that the value of the integration is 1 to satisfy the PDF, right? Valid PDF. So let's do the integration in the range 0 to 1 of function to 1 minus x. This is dx. So this is simply 2 minus 2 times 0 to 1 x, right? 2 minus 2 x square divided by 2, 0 to 1, and this is 2 minus 1, which is 1. All right, so this is a valid PDF because the integration is 1 and the values of the function are positive. We can also draw the graph of this function. This is very easy function, so we can draw the graph. So the graph will be something like this, because you can find out the x-intercept and the y-intercept by putting the values here. So the function is fx equals to 2 1 minus x, right? So you can put the values x equals to 0 and you'll get the value of y. So fx equals to, this is simply 2, right? So this value is 2, and similarly you can put the value here, this is 1. You can, this is simply 2 minus 2x equals to 0. You can put the value y equals to 0 and you will get the x-intercept. So this is 1. All right, now we can find out the area of this triangle. So the area of triangle is simply 1 by 2 times base into height, right? So base is 1 and height is 2, right? So this is 1. So now we can see that the area of this triangle is 1, which means the PDF is, sorry, which means the function is a valid PDF. All right. Now let's do one more question. Suppose the function is 5e to the power minus 5x, where x is greater than 0. Now you can see that this function, this value will always be positive because the exponential is always positive. Okay. So the first condition is satisfied. Now the second condition, we need to integrate and so that this is, the integration is 1. So we need to integrate in the range 0 to infinity 5e to the power 5x dx. Okay. So this is very simple. We can separate the constant and integrate the exponent e to the power 5x dx. So this is 5 e to the power minus 5x divided by minus 5, and the range will be applied here 0 to infinity. So this is 5 will be cancelled. So this is simply minus 1, 0, minus 1, and this is 1. All right. So the integration is 1. So this is a valid PDF. Now if you don't know what is the value of e to the power minus infinity, then it will be really hard for you to integrate this, right? It will be really hard to calculate the value. So let me give you some trick to remember the values of log 0, e to the power minus infinity, something like that. So suppose this is a number line and here we have minus infinity, this is 0 and this is infinity, and on top of this there is 0, there is 1, there is infinity. Okay. So this is basically a trick for you to remember this. Here we have log and this here we have exponential. So whenever you see log 0, the answer is minus infinity, and log 1, the answer is 0. Log infinity, answer is infinity. Similarly, when you see e to the power minus infinity, the answer is 0. E to the power 0, the answer is 1. E to the power infinity, the answer is infinity. All right. So this is how you can remember this, because in this integration here I used e to the power minus infinity. Here e to the power minus infinity, which is simply 0. That's why I put the 0 here, right? So you need to know these values, otherwise you'll have a hard time doing the integration. Now let's do one more problem. Suppose fx equals to 9x a to the power minus 3x, where x is greater than 0. Now again, the value of the function is positive because x is greater than 0 and the exponent will always be positive. So the value is positive and we need to integrate this to check the second condition. So here we have two functions. Here we have algebraic as well as exponential. So we need to use the by parts rule, integration by parts rule. But we have a trick. I'll show you a trick which you can use in this case, which will help you, to do the integration easily. So let's look at the trick first. So there is something called gamma integration. Gamma integration. So it has a form like this. The range is 0 to infinity and the function is x to the power alpha minus 1 a to the power lambda minus lambda x dx, and the integration of this form is gamma alpha lambda to the power alpha, where alpha is a positive constant, positive integer. Okay, this is the integer, positive integer, and lambda is greater than 0. So alpha is a positive integer and lambda is greater than 0. So when these conditions are satisfied and the function is in this form and the range should be 0 to infinity, then the answer is gamma alpha divided by lambda to the power alpha, where gamma alpha is simply alpha minus 1 factorial. Okay, so for example, suppose this is 0 to infinity and the function is x times e to the power minus 3x dx. So you can see in the place of alpha we have 2, because you can write 2 minus 1, which is simply 1. So in place of alpha we have 2 and in place of lambda we have 3. So the answer will be, and the range is 0 to infinity, right? So the answer will be alpha gamma 2 divided by lambda, which is 3 to the power alpha, that is 2. Okay, and this is simply 2 minus 1 factorial, and this is 9. So the answer will be 1 over 9. All right, so let's do the previous question. Now in this question the integration is 0 to infinity 9 x e to the power minus 3x dx, right? And we already solved this part. This is the constant. So the answer of this part is basically 1 over 9 times constant, right? So this is 1. So the value of the integration is 1, which means this is a valid PDF. Okay, so you need to remember this gamma integration. You need to remember the form, the range, and the value, the answer of the integration. Okay, now let's move on to the CDF of continuous random variable. We talked about PDF. So now let's talk about CDF of continuous random variable. So the notations are capital F x, or we can write simply capital F x, or we can use this symbol as well. All right, now let's look at one example. Suppose the PDF is 2 times 1 minus x and the range of x is 0 to 1, and you are asked to calculate the probability where random variable is less than or equal to 0.4. So the starting point of x is 0, right? And the end point of x is 0.4. You need to integrate from 0 to 0.4, and that will give you the CDF. So 0 to 0 0.4, your function is 2 times 1 minus x dx, and this will give you the CDF. So this is CDF, right? Similarly, if it is given random variable x is less than 0 0.4, so this is again same 0 to 0 0.4. It doesn't matter whether there is equal to sign or not, because in continuous random variable the area at a point is 0, probability at a point is 0, so it doesn't matter whether there is equal to sign or not. We'll simply integrate from 0 to 0 0.4 and then function dx. All right, now suppose you are given to calculate probability where x is greater than 0 0.2 but less than 0 0.6. So this is very simple. You'll simply integrate from 0 0.2 to 0 0.6 fx dx. All right, and suppose you are asked to calculate the probability at a point 0 0.5 suppose, then you can write this as 0 0.5 x greater than or equal to 0 0.5, right? So the integration will be from 0 0.5 to 0 0.5 fx dx, and this is 0. So at a point probability is always 0. We can only calculate interval probabilities in continuous random variable. Again, we can only calculate interval probabilities in continuous random variable. All right, so if you want to go from PDF to CDF, you'll use integration. So from PDF to CDF, you will use integration. Now, what will you do if you want to go from CDF to PDF? You'll use differentiation. Okay, so the differentiation is the opposite of integration. So whenever there is some CDF and you are asked to calculate the PDF, you'll simply use the differentiation. All right, now let's do one question. Suppose you are given a CDF 0 when x is less than 0 and when x is greater than 0, the CDF is 1 minus 2 divided by 2 plus x to the power cube, and you are asked to calculate the conditional probability where x is greater than 3 given x is greater than 1. So you are asked to calculate the probability of this thing. Now you can consider this as A and this as B. So you know the formula of A given B, which is simply A intersection B divided by B, right? So in this case, this will simply be x greater than 3 intersection x greater than 1 whole divided by b x greater than 1. All right, now what is this? X greater than 3 intersection x greater than 1. So this is simply x greater than 3, right? If you draw a number line, this is 1 2 3, so this is x greater than 1 and then x greater than 3. So the common area will be greater than 3, and then in the denominator you have x greater than 1. All right, now you can write the numerator as 1 minus p x greater than or equal to 3, right? Because you are calculating the area greater than 3 but the whole area is simply 1 in probability, right? So you can subtract this area. Okay, you can subtract this area from 1, you'll get this area, right? And again in the denominator we'll do 1 minus px greater than or equal to 1. All right, now what is this thing? What is this thing? This is nothing but CDF up to point 3. The starting point will be 0 because in our question you can see the starting point is 0 and the end point will be 3 and 1. All right, so this is simply, and you are given the CDF, so you don't need to do anything. This is the CDF, right? CDF is given, so you'll simply put the value of x over there. So this is simply 1 minus 2 divided by 5 to the power whole cube divided by 1 minus 2 by 3 to the power whole cube. Okay, and if you solve this you'll get 3 divided by 5 whole cube. All right, so this is how you can solve the problem of continuous CDF. All right, now let me give you some tricks, you know, to help you in solving some questions. So whenever you are asked to calculate the probability when x is greater than a and less than b, you can change this in the form x is less than b, probability x is less than b, minus probability x is less than or equal to a. All right, similarly, when you are asked to calculate probability x is greater than x less than or equal to b, then you can change this in the form x is less than or equal to b minus probability x is less than or equal to a. When it is given probability x is greater than or equal to x and x is less than or equal to b, then you can do probability x is less than or equal to b minus probability x is less than a. Okay, and when probability x is greater than or equal to a but less than b, then you can do probability x is less than b minus probability x is less than a. All right, and when it is given probability x is greater than a, then you can simply write 1 minus probability x is less than or equal to a. And when probability x is greater than or equal to a, you can write 1 minus probability x is less than a. All right, so using these tricks you can find any CDFs. Okay, so now let's stop here, and in the next video I'll go in depth of the distributions like exponential distribution, binomial distribution, and some of the distributions. Okay, so the concepts of the PDF and CDF will be applied in, you know, calculating the expectations, variance of the distributions. So let's stop here. Thank you so much for watching this video.